Hello, my name is Stella Bunarelli and I will present you a recent paper called HyperReenact, one-shot reenactment via jointly learning to refine and retarget faces. Neural face reenactment methods aim to generate high-quality realistic talking head sequences that preserve the identity and the appearance of the source image and mimic the facial pose defined as the head pose orientation and the facial expressions of the driving images. Current neural face reenactment methods face several challenges that limit their ability to generate high-quality realistic images that accurately mimic the target facial pose. Firstly, the generated images have often unexpected visual artifacts and deformations, especially when the source and target faces have large head pose variations. Secondly, the facial pose movement is not explicitly disentangling from the appearance of the input faces, which results in transferring identity details from the target images, limiting their applicability on cross-subject reenactment. Finally, in order to preserve the source identity details, some methods require few-shot subject fine-tuning, which is computationally expensive and time-consuming. In this paper, we propose a novel model called HyperReenact, which performs both self- and cross-subject reenactment, and operates under one-shot settings without requiring any subject-specific fine-tuning. We show that our model achieves state-of-the-art results even on extreme head pose variations. We propose to use a pre-trained StyleGAN2 model which can generate high-quality facial images. In order to edit the real images, we first need to embed them into the latent space of StyleGAN2. However, current inversion methods suffer from the reconstruction editability trade-off, where trying to achieve a faithful reconstruction may make it more challenging to edit specific semantics of the generated images. We draw inspiration from HyperStyle, a real image inversion method that modifies the ways of StyleGAN2. HyperStyle is able to perform accurate image reconstruction, however it fails on facial pose editing by generating many visual artifacts and deformations. We propose HyperReenact, a method that learns to alter the weights of StyleGAN2 to perform both refinement of the source identity details and reenactment of the source face in the target facial pose. During training, we first extract the appearance and pose feature maps using the corresponding pre-trained encoders. We then propose to fuse the two feature maps using the Reenactment module. Our hypernetwork takes as input the combined feature map and outputs an offset for each layer of the StyleGAN2 generator. The generator, using the inverted latent code W that corresponds to the source image and the updated weights, generates the reenacted image that should depict the same identity with the source image and the facial pose of the target image. We train our hypernetwork using a curriculum learning scheme where we gradually increase the complexity of the training data. We first train our network on real image reconstruction task where the source and target faces are the same. During the second training phase, we train our model on self-reenactment where the source and target faces have the same identity but different facial pose. Finally, we fine-tune our model on cross-subject reenactment where the source and target faces depict different subjects. We compare our method with 6 state-of-the-art methods. Here you can see our quantitative comparisons on self-reenactment. As shown, our model presents compelling results by successfully preserving the source identity details and accurately transferring the target facial pose. We also present our quantitative and qualitative results on cross-subject reenactment. Our method outperforms all methods on identity preservation while also effectively transferring the target facial pose without producing unexpected visual artifacts. Additionally, in order to evaluate our method on the challenging task of large head pose variations between the source and target faces, we built a benchmark set containing image pairs from the VoxelLab dataset where the average head pose distance is bigger than 20 degrees. As shown, our method, even on the challenging task of extreme head pose variations, is able to generate realistic images without many visual artifacts, compared to other state-of-the-art methods, where in these cases produce unrealistic faces. Thank you. For more information, please visit our project website.